IP addresses. So for this problem, we are giving us a string and it's going to be random numbers. We just want to check if that is possible. Those kind of string can be split by dot, and then it's gonna become an IPv4 IP address. Yeah, so this is definitely IPv4. And there are two cases in this example, and in this example it's going to be 0, 0, and it's going to be valid. Yeah, and in this case it's going to be such kind of cases, and we should know that. So this is not okay because there's going to be a padding 0 for this 0, 1, 1. It has to be 11 instead of 0, 1, 1. And this is some random numbers that is invalid. Yeah. So S consists of digits only, and the length is 20. Maybe if you say this is 20, maybe it is backtracking. Yeah, actually it is backtracking because backtracking is the easiest way to solve the problem. We just need to backtrack and find all the possible cases. Yeah. Now let's just start coding. I'm going to prepare the length of the string, and I'm going to define the backtrack function, and I going to be index. It's going to start from 0, and the answer going to be a valid answer, a temporary answer like that. Yeah, but I'll put it inside a array currently. I will change it later maybe. So the condition is that we're going to check I and the length of the answer. Yeah. So if the length of the answer is 4 and I equal to n, definitely I've already found a valid answer. So I'm going to put it inside of the result array. I'm going to use a dot join the answer array, and I'm going to give a return to let it run fast. Now I'm going to use another index j to find this is going to be a valid split. Yeah. So for j in range I 2. But the minimum length going to be, the maximum length going to be 3. So for this example, or it can be 2 or 1, but it cannot be more than 3. So I'm going to control it. So from here, I'm going to control it to I plus 3 with n. Now I want to check if I equal to j. This means there's only one digit, so this is valid. Yeah. So I'm gonna go for the backtracking. It's gonna be here gonna be j plus 1 because this valid split, I need to go to the next, and what's left behind is the answer array plus equal plus 2, yeah, the string from I to j plus 1. Yeah, I think basically that's all about it, but let me just prepare an empty array result and run the backtracking, and inside it's going to be 0 and empty array, and finally I'm just need to return the final result. But this is just one case, I didn't finish all of them. Yeah, and we have to turn it into an integer. If it is not one digit, it might be 2 or 3 digits together. So yeah, I needed to check that j plus 1 if this is less than or equal to 255, and si should not equal to 0 because there's no leading 0. Yeah, if it has 2 or 3 digits and the first one is not 0, so yeah, definitely it is valid. So we're gonna go for the backtracking, and in this way we can find all the cases. Let me just run it. As you can see, it works, and let me just submit it to check if we can pass for all testing cases. Yeah, as you can see, we pass for all testing cases, and the speed, I think it is okay. It is 50%. Maybe you wanna speed up a little bit. Maybe, yeah, you want to check it like this. If the length of the array is more than 4, definitely, yeah, we just need to have a return because we want to, yeah, run a little bit faster. Yeah. As you can see, it is much faster than before. It is already 3 milliseconds. And what about the time complexity? Because for the splitting, this is a trimming, this is a branch. For this branch, there's going to be a trimming. So it depends on the string. So if it is 20, so if it is 20, definitely it is invalid, because at most we're going to have like 12 digits. Yeah, I mean if we have 20 digits, definitely it is invalid. So for our checking, actually it is only 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 like 12 digits, and for each part it might have a splitting. Yeah, so how many splittings? It is like 12 splittings, so it is 2 to the power of 12. Yeah. But from here we might split it like this one or this one. Yeah, but basically we can understand it as for each part, for each area, we're gonna have a split, maybe here or maybe here, we don't know. Yeah, but at most we're gonna have four splittings. Yeah, so it's gonna be something like we have 12 digits. It's gonna be something like 12 times 11 times 10 times 9. So this is gonna be the time complexity. Yeah, first of all we can find one place and then maybe another place. Basically it's going to be like that, but actually it's going to be much smaller than that. That is why it's so fast. I think that's all about it. Thanks for watching. See you next time.